Open loop transfer function of a unity feedback system is given by G of S, that is A over S into 1 plus ST. By what factor should the amplifier gain A be multiplied so that the damping ratio is increased from 0.2 to 0.6? Here, the characteristic equation is nothing. Closed loop transfer function is equals to A by S plus S square T plus A. So if we take T as a common, S square plus 1 by Ts plus A by T. Here 2 zeta omega. Suppose if we compare this closed loop transfer function, what we got here with the standard transfer function, we will get 2 zeta omega n as 1 by T and omega n is under root A by T. Here zeta is 1 by 2 omega n T. So 1 by 2 under root A by T into T. So 1 by 2 under root AT. This is the zeta. Zeta 1 is 0.2, which is 1 by 2 under root A1T. Zeta 2 is 0.6, 1 by 2 under root A2T. So zeta 2 by zeta 1 is nothing but 3, which is equals to under root A1 divided by A2. So A2 is nothing but 1 by 9 A1. So the gain must be multiplied by a factor of 1 by 9. That is, option C is correct. Signal consists of a periodic component, a random component, and a DC component. The autocorrelation function is shown in the figure. So we have to decide the average power present in the random component. So in order to decide that one, first of all we have to subtract the DC power present in the autocorrelation function, which is not because of a random component. So DC power is equals to 1.5. So autocorrelation function due to the periodic autocorrelation function RP tau plus autocorrelation function due to the random component is equals to RYY of tau minus 1.5. So here this is RP of tau. This periodic autocorrelation function is this is plus 0.5, this is minus 0.5. Whereas autocorrelation function of a random component is this is 1 minus t, that is tau. So average power of a random component is nothing but Rx of 0, which is 1 watt, that is option D is correct. Signal m of t is given as 2 into sine of 1000 pi t and the phase sensitivity constant is 5 radians per volt. Bandwidth of the PL signal is. Here, suppose if we are indicating PM signal with AC cos omega t. Here omega, that is, this is nothing but, suppose I am pi of t, this is the phase. So pi of t is equals to omega ct plus kp dm of t by dt. kpm of t, this is because this phase, because m of t is in volts, the kp must be radians per volt in order to add to this constant to the radians. So here d pi of t by dt 1 by 2 pi is the instantaneous frequency, which is equals to fc plus kp by 2 pi dm of t by dt. So here delta f max, which is nothing but a maximum frequency deviation, is equals to kp by 2 pi dm of t by dt max. So kp by 2 pi d by dt. M of t is nothing but 2 into sine of 1000 pi t max. So after getting delta f max, if we substitute bandwidth in bandwidth, that is 2 into delta f max plus fm is equals to 11 kilohertz. That is option B is correct. Schematic is shown below. A white Gaussian